In the last video, we saw how to modify polyatomic ions from the 8 version. We saw how to make the ite, the per 8 version, and the hypoite version by changing the number of O's that we have. There's another type of polyatomic ion modification that you can make that involves adding an H to a polyatomic ion that you've commonly seen. So let's do an example here. We're going to take, oops, let me fix that. We're going to take carbonate and add an H to it to make another polyatomic ion that you may have seen before. That polyatomic ion is called hydrogen carbonate. So hydrogen carbonate. And so to make hydrogen carbonate, you simply add an H in front of the H of the CO3 that's already there. You're not going to modify the number of O's this time. What you're going to do is you're going to modify the charge. Every time you add an H to a polyatomic ion, that H contributes a positive charge to it, a 1 plus to it. So if your polyatomic ion was -2 initially, when you add the H, it's going to become -1. It goes up by 1. And when I say up and I go to 1 to 2 from 1, it looks like it's going down, but it's not. Keep in mind these are negative numbers here. So when I add an H and add 1, it goes towards the positive. So here we have hydrogen carbonate. You might also call it bicarbonate. You can do the same thing for many polyatomic ions. So I can take phosphate and I can add an H in front of phosphate. So HPO4. I don't change the number of O's, but I can see that phosphate was 3-. When I add an H, now it becomes 2-. So this would be biphosphate, or you can call it hydrogen phosphate. Sometimes you can add more than one H. So for example, if I decide to add 2 H's instead of only 1 H to my phosphate, I'd have H2PO4. PO4 started off with -3. I added 2 H's, so that means I'm adding 2 positive charges there, so that becomes -1. This here, rather than being called hydrogen phosphate, it would be called dihydrogen phosphate. So whenever you add an H in front of your polyatomic ion, if it's only one H, you basically call it hydrogen name of polyatomic ion, so hydrogen carbonate, for example. This one here would be hydrogen phosphate. An alternative to that, when you only add one H, is calling it bipolyatomic ion. So you could call this hydrogen carbonate bicarbonate, and you can call this hydrogen phosphate biphosphate. If you add 2 hydrogens, you need to make sure you add 2 positive charges. And you would call that, instead of hydrogen phosphate, you would call this dihydrogen phosphate for the 2 hydrogens. And so again, that can be done for a variety of different polyatomic ions that you start off with. So now that you know that, you can derive many different polyatomic ions from the regular 8 version. We'll do a few problems where we have to name some compounds that contain polyatomic ions, and we'll also do some that where you have to write formulas from the names. So let's do an example that you might have in your homework package here. We'll try this one over here, NaHCO3. So your first step is to name the metal. The metal is sodium. And your second step is to name the polyatomic ion. So underline the polyatomic ion, it has the H and the CO3. You know that CO3 is carbonate and there was an H added to it. So if there was an H added to your carbonate, only one H, we would call this sodium, and then the polyatomic ion would be hydrogen carbonate, or you could say biphosphate. I'm going to write down biphosphate, or sorry, I should say bicarbonate. Bicarbonate, or hydrogen carbonate. Suppose you had one that you had to write a formula for. So let's do sodium dihydrogen hypophosphite. Now this one is a long one. You're combining many rules here to figure out what this polyatomic ion is going to be. So let's start off with the phosphite part. You know that phosphite probably comes from phosphate, PO4. So phosphate was PO4, 3 minus. And in this case, so you have hypophosphite. So phosphite would be one below, so PO3, 3 minus. And hypo would be one below that, so you have PO2, 3 minus. Now you're not done yet because you'll notice that you have dihydrogen in the front, which means you have the hypophosphite, but you've added 2 hydrogens to it. So you have H2 PO2, but now because you added the 2 H's, this minus 3 becomes a minus 1 because you add 2 positive charges. So this here would be dihydrogen hypophosphite. So for sodium dihydrogen hypophosphite, you would have Na with a charge of +1 and H2 PO2. I'm going to put the -1 charge up here, put this in brackets, because you don't want to change the polyatomic ion itself. You can do your crisscross. And the end result will be that you have 1 on both sides. So Na1, H2, PO2, 1. And because you have 1s, you don't need to write them in. So you can just erase the 1s. And because you have a 1 outside of the bracket, you can remove the bracket. So using your knowledge of the rules to come up with different polyatomic ions or to derive polyatomic ions, you can figure out the formula for almost any polyatomic ion that you see, as long as you have some general knowledge of the 8 version of it. We'll do one more problem together. So I want you to try to name Cu H2 PO5 2. So the first thing I need you to recognize, I'm just going to finalize my formula here, is that you have a multivalent element in here, copper. And then you also have some weird polyatomic ion, this H2PO5. So let's take a look at what that name would be. You know that it probably comes from the phosphate initially. But you're above the O4. You have PO5. Which means that this is probably perphosphate. So now you just have to realize there's a 2 over here. You added 2 H's in front of it. So you actually have H2 PO5. And since you added 2 H's, that would be minus. So you have dihydrogen perphosphate in this example here. Because you have dihydrogen perphosphate, you know that your compound is copper 2 dihydrogen perphosphate.